Well, the fundamental objects that we deal with in calculus, we call them functions. So this begs the question, what is a function? What is the concept of a function in mathematics? So here we will take 4 examples, and with the help of these 4 examples, we will finally arrive at a formal definition of a function in mathematics. Now basically a function, the idea of function arises when one quantity depends upon some other quantity. So let us take our first example. Well, this is image of a circle having radius r, and we know the area of a circle having radius r is given by a equals to pi r square. A is the area of the circle. Now here r can take any non-negative number, okay, and for each value of r there is one value of area. So again here area as a quantity is depending upon another quantity, radius. Now as r can take values independently, of course the condition is that it should be greater than equals to 0. We call r as independent variable and a as value of area depends upon radius, so a as dependent variable. Okay, so now this is showing the relation between a quantity a in terms of another quantity r. We can write it as a equals to a function of a is a function of r. We read it as function of r. So this equation a equals pi r square explicitly giving a rule using which we can find the area of a circle. Now this is our second example. This is some data given in the form of a table. Now this table shows world population in millions, okay, in a given time stamp. Okay, so say at time stamp t equals to 1920, the world population is 1860 millions. Now in this case there is no explicit formula as was there in example 1, but yes, here the population depends upon the time stamp t. So we can here again say p, if p represents population and t represents time, so we say population is a function of time, right? So t here we'll call independent variable, p as a dependent variable, and this is a rule which is given in form of a table. So again in this case for a given value of t we are having a number which is giving the value of p. And this is our third example, which is a word problem. In this case the C symbol represents cost of mailing an envelope. You know, we mail envelopes from post offices, right? Now we know that cost depends upon the weight of the envelope, right? Again in this case there is no simple formula as was the case in example 1. Okay, but here again we know that the cost depends upon the cost quantity depends upon the weight quantity. So we can again say here cost is a function of weight. For each value of weight of the envelope there will be a corresponding number that will give the cost of mailing. And this is our example number 4. Here a symbol denotes the vertical ground acceleration and t denotes the time elapsed, right? This graph has been produced with the help of a seismograph, and this represents a data of an earthquake that took place in 1990s in Los Angeles, US of America. Okay. So again in this case the a quantity depends upon the t quantity which is given with the help of this graph. So in all these 4 examples we have taken here, we have seen that there is a quantity in first example r, in the second example t, in the third example it was weight, in the fourth example it was again time. For each value of this quantity there is a associated value of another quantity. In first example it was area, in second example it was population, In third example, it was cost of mailing. In fourth example, it was acceleration of the ground, right? So there is a rule which is associating each value of one variable to another variable, okay, and this rule we are denoting by a symbol f, and we call it function, because these rt wt on the left hand side, they can take independent values. We call them independent variables. The other quantities a, p, c and a, they take their values depends upon the independent variables. We call them dependent variables. So after seeing this pattern, let us make a generalization. Suppose there is a quantity. For each value of this quantity x, we are getting another quantity, a quantity which is represented by symbol y. And how do we achieve? We find the value of y with the help of a rule, and that rule is denoted by f symbol, which we are going to call a function. So now let us give a formal definition of function. A function f is a rule. F is the notation for function that assigns to each element x in a set D exactly one element called fx in a set E. So we can easily understand this definition with the help of this illustration. F is a function which is nothing but a rule which is assigning each element. This element is represented by x to another element. We are denoting it by fx in a set E. Now this set D, that is collection of all elements x, is called domain of function f. This set E is called codomain of function f. Collection of all these fx values is called range of f. So what is the range of f? Range of function f is all elements fx belongs to set E such that x belongs to domain D. At times we denote value of function at x fx by another variable y, and we read it as value of function at x is equals to y. Here x is independent variable, y we call dependent variable, f is notation for function, and we can interchangeably use y for fx and fx for y. So I hope after watching this video you understand the concept of function in mathematics. Thank you.